So we've talked about arithmetic sequences where you add to get the next term, and so today we're going to talk about geometric sequences. A geometric sequence is a sequence in which a common ratio r is multiplied to each term to get the next term. And be careful that you remember that this definition says you are multiplying to get the next term. So to go forward in this sequence, we have to be multiplying. So the first example gives us 3, 6, 12, and 24. Notice what you're multiplying by. You're multiplying by 2, so r is 2. On the next example, you may think, well, it's just changing signs. You're right, but that's because you're multiplying by a -1, so your r would be a -1. The trick on this third one is you may think, well, I'm dividing by 3. You are dividing by 3, but that's the same as multiplying by a third. So your r is 1/3 because it has to be what you're multiplying by. The fourth one is simply not geometric because you're not multiplying by the same thing every time. So there's not one specific r value. So there is a way that we can write an explicit formula. If you wanted to know how to find any term in a geometric sequence, you would need to write the explicit formula. So for geometric sequences, that's a sub n equals a sub 1 times r to the n minus 1 power, where a sub 1 is the first term, r is the common ratio, n is the number of the term, and a sub n is the nth term. So in this example, it says write the explicit formula for the nth term of the sequence 4, 8, 16, 32. So notice that you are multiplying by 2 every time, so our r value is 2. Now, if we take this information and we substitute it into the formula, we would get a sub n equals 4 times 2 to the n minus 1 power. We put 4 in because that's the first term, that's the a sub 1. Now, technically, we can leave it as this, and that is totally acceptable, and you are totally allowed to do that. However, I'm just showing you how you could simplify further. So if you want to take a moment to look at how we would simplify that, you can look at that. Now, if I extended this question and said, okay, what if I wanted you to find simply the 8th term of the sequence? Well, go back to the sequence. You already have 4 terms. If you're trying to find the 8th one, it wouldn't be that hard to multiply by 2 a few more times. So if you did that, you're going to get 512. But what you could also do is use the formula. You could take 8 and substitute it back in here for this n value, and do 4 times 2 to the 8 minus 1 power, where that's 7. So 4 times 2 to the 7th power would be 4 times 128, which is 512. So whether you decide to just multiply it a few more times or use the formula, you'll get the same answer. Another example, it says write the explicit formula for the nth term of the sequence. Now, you may say, I can't even tell with these numbers what we'd be multiplying by. So what you can do in a geometric sequence is you can, since you're multiplying to go forward in the sequence, division is what you could do to go backwards. So if you divide -45 by 135, 135 by -405, -405 by 1215, all of those are going to reduce down to a fraction of -1/3, and that is your r value. So then taking the explicit formula that we learned above, a sub 1 is 1215, r is the -1/3. Notice the parentheses around that -1/3. You need to make sure that you put those parentheses around it. Now, might we be able to simplify? Maybe. Should we? It doesn't matter. We can leave it just like this. So then if I asked you to find the 7th term, you would just plug in 7 for that n value. And when you do that, you're going to end up with 5/3. Or you could have just multiplied by -1/3 a few more times. Either way, you're going to get to 5/3. The geometric mean of any two positive numbers is the square root of the product of those numbers. Now, I know that sounds like a lot of math terms right there, so let's just break it down. Product means to multiply, and then you're going to take the square root. So finding the geometric mean of 28 and 5,103, you're going to multiply 28 times 5,103, then you're going to take the square root. Just use your calculator. Another way we could ask the question would be to find the missing term of the geometric sequence. Same concept, you're going to multiply 3 times 27 over 4, and then you're going to take the square root of that. Now notice when you multiply, you get 81 over 4. So when you take the square root, just take the square root separately. The square root of 81 is 9, and the square root of 4 is 2. Your homework is on page 614.